We're going to start with looking into client-server applications. Now, the fundamentals of these aren't really all that deep. Where the trick is going to come in is where we're going to get into how do we design these? How do we come up with the patterns that are going to get us the solution we want to? So this first one is we're going to get just the idea of, hey, we're going to be building more than one application. Everything up to now you've probably built has been one program, either a main program or some GUI program or something like that, command line or GUI. But there's been one result. You hit the run button, it does one thing. Now we have two applications to start up to get any interaction going on. We have a server, and then we have one that's going to go and call the server, and we have one that we're going to play with. But you could have many of them. But why do we bother doing this? I mean, if we can create a bunch of little applications do the job on their own, why would we have lots of them? What's the value that we're trying to put in by adding this complexity of what we're going to be learning right now? Well, the idea of this is we're going to be able to share data. We want to have more than one person being able to work on this. In this class, you're going to do all this client-server stuff on your machine. But realistically, what we would be doing is we create an application where a bunch of people would be sitting out throughout an office place or around the world that would all be going off to the server and sharing information, retrieving information, updating information, working together to be able to solve those big business problems. So think of it this way. You have a call center, you call in, and you start working on a ticket for someone. For whatever reason, the call gets disconnected, somebody calls back in. Well, you don't have to go to find the exact same person you were talking to, which if you were writing everything down in pen and paper, you'd have to. If you have a client-server system and the notes are updated on the server, different people are talking, they all go get the same information, they share the same information. This is what we do within the internet. So the key about this is we need to figure out how do we share information between two applications. If we don't, two applications run all the time. They just kind of pass in the night. So like right now, you're probably watching this video at the same time you have, browser up in the background, and you have, maybe Microsoft Word over on the side, maybe you have NetBeans up, you have all these different things going on. Those applications don't talk to each other regularly. We have to find a way to share information. Now, one of the ways we can share it is through files. Each application can have a file, and they can both read the file, but that's offline, and typically there's restrictions on how many applications can access and certainly change a file at a time. So we prefer real time, and so what if we did this wild and crazy internet-y thing the kids are all talking about? And that's exactly what we're going to do. So the core of basic modern communications is Ethernet. Socket communications. We can talk from one computer to another computer over a connection called a socket, which is identified by the address of the computer and a port number. And so the port number is basically the protocol in which you're talking over of sorts. Common port numbers is like HTTP is port 80 or HTTPS is port 4433. The idea is I'm connecting to a specific I'm connecting to a specific application. So when I go to a computer and ask for port 80, I'm asking for the web browser, not the Minecraft server that might be running on the same computer. Or if we go to HTTPS, I'm going to the secure version of that. Now, all those applications can be on the computer. It's like calling into a business. I call into a business. I have an extension by which I can go get to a specific person. So in Java, it enables the socket by having one application open up a socket to listen on request for requests on, and the other application opens up a request to that socket. It doesn't have to be a Java application that opens up the request. It's easier if you do it that way, but it's not required. And so this is a point-to-point communication. This is a telephone call. I'm not broadcasting to everybody out there. I'm not streaming this information. I'm just making a point-to-point communication. So in our Java code, let's take a quick look at this. It's really simple to enable this technology, but we want to understand exactly what these do. Now, this is all stuff that comes straight out of the Java library. You get it for free. There's nothing special on top of here. And so a server socket is an object in the Java hierarchy that allows you to go through and create an instance on some port numbers. So you see the number 55 here. The first line on 55 is indicating the port number. It's pretty much any number that's a positive integer inside of there, up to some thousand, 20-some thousand or something like that. Maybe 60,000. I don't remember off the top of my head. So there's a bunch of numbers to choose from. And then from that socket, I can then, once I've created it, say I'm going to listen on this port number. And that line of code basically just goes and reserves that socket. The only reason it doesn't work is if for some reason somebody else is already using that extension. If line's busy, line's taken, he won't let me use that. And so then I accept the next incoming request. So basically I go to a phone, I sit down next to it, I wait for somebody to call. From there, once I've accepted a request, then I get a regular socket object. And in the socket, I can go get input streams and output streams, which are ones and zeros coming in and out of the application, by which I receive information and I send information to my caller. And so I can use any of my standard file I/O stuff that you learned about in your previous class to be able to talk about it. I can talk text, I can talk ones and zeros, I can talk anything you can normally do there. I can send music files or whatever I want to do back and forth. So in this case, we're doing a buffered reader, which is text, and we're doing a print writer, which is text. So we receive one line at a time, just like you'd be reading from a file here. So at this point, once we've gone by the first couple lines of code, the socket stuff, everything else here is just standard file I/O stuff. So I open up some buffered reader, buffered writer, print writer, that's input and output, and then and they're basically two streams there. They're not the same thing. It's not a file. It's one's the input, one's the output. And then I can read a line at a time, and while the line's unequal to null, I can print that line out and then read the next line. And that's what the server's doing. In this case, the server's just simply reading in a bunch of lines of code and spitting them back out to the screen. All right, and that's the server socket. As simple as that. Really, these first two lines of code is all that's interesting here. On the client side, it's not much more difficult. So the socket, its job is you can just create it, and then you connect from that socket to any INET, internet address, so an internet socket address. A local host then is the machine I'm currently working on. It's the same as 127.0.0.1. It's the machine you're currently working on. You're looking internal. You're not going across the internet at all. And the most important thing here is the second number. I'm going to port 55. So I'm looking on my machine for an application that's connected to port 55. If the other one's not connected to the same thing, I can't talk to it. If it's already taken by another application, I attempt to talk to it, and it'll be confusing. It's like picking up a phone and dialing the wrong number. The person doesn't know what you're talking about. So there's a couple things that can go wrong here, but mostly, if the other application's running, it's also on 55, it'll connect. It'll be fine. At that point, then, I have the print writer that I'm now writing things to. And I get from that socket that I just created, I get the output stream of what I write to, and I'm writing test 1, test 2, test 3, and then I'm flushing it. Now the flushing it's really important here. We'll see this when we do the demo. If you don't flush it, it won't send it. This isn't like a file where I can just close it and it automatically works. When I go and print something out, I have to say send this now. The print line doesn't send it. I can queue up a bunch of stuff and send it all at once. And that makes the internet operations a little bit more efficient. It allows you to control the flow of data a little bit better, but that's what's going on here. So I print, then I flush it and send everything. Then I close it and it's done. Once it closes here, it also closes on the other side. We both hang up and the applications end and it's all over with. So this is the foundation by which this socket stuff's created. Again, it doesn't get us to a client-server application. It just enables communication of that. And the demo that we're going to see separate from this will go through and guide you through that. We'll actually build this code. We'll see some of the faults and flaws and errors that can come up by doing this. But this is the foundation by which we can go and see exactly how we go and build to a client-server application.